Hey there everyone, welcome back to my data structures and algorithms series here on YouTube. Today we're going to learn about a really useful data structure called a linked list. Don't worry if this is the first time you're hearing about it, because I'll explain it in a way that's easy to understand. So let's get started. Okay, so let's start with the basics. First of all, a linked list is another way to store and organize data. Imagine it like kind of like a chain of connected blocks where each block holds some kind of information and points to the next block. It's different from a list because it doesn't need to store all the data together. Instead, each block knows where the next block is, and that's kind of how it works. So now let's look at like a little example to help us like understand it better. So imagine that we're creating a playlist of songs. We're going to use a linked list to store the song in the order that we want. Now, in this example, we have a song node class over here, which represents a singular song. Now, each song has a name and knows which song comes next. Now, the playlist song, it manages our linked list. So here we can add songs to our playlist using the add song method. So let me just explain it a little bit more in depth. So this is our class song node, and in this class, it's pretty simple. By the way, if you don't know about classes and objects, I highly recommend that you check out that video that I also have at my YouTube channel. I'll link it in the description because that's really important to understand this concept of linked lists. So the reason linked lists are so cool is because they're really dynamic. That means that they don't have to be really traditional like lists are. So here we're going to use the initialization function, and here we are going to kind of initialize a single node, and now the linked list is going to be built on top of these nodes. It's going to be multiple nodes stacked on top of each other. That's what a linked list is kind of. That's the purpose. So now this is the playlist class, and here again we're gonna use the initialization function to kind of initialize it. So every linked list is gonna have a head, which is gonna be the first node in the list. Now we're gonna have an add song method. Now again, in classes you can have as many methods as you want. Methods are just a way to kind of manipulate the objects inside the class. So here we're going to have a new variable called new song, and here we're going to call upon this song node object to create a new song. Now, if self.head is none, which means that if the linked list is basically empty, then our new head or our new first node is gonna be this new song. Otherwise, if the linked list already has a head, this is the current song is gonna be the ahead, and then we're gonna keep going until we replace the current song with the next song, basically. So this whole like operation here, what we're trying to do is we're trying to add the newer node into the linked list kind of in a dynamic way. Okay, so now that we have our playlist, let's see how we can go through it and do some common operations on the playlist. So in this example, we're going to go through each song in the playlist and we're going to print its name. We're also going to demonstrate two common operations, which are searching for a song using the search song function and calculating the length of the playlist using the get playlist length method over here. So in order to do that, we first have to create a playlist and add 3 songs to it. Now we're going to traverse the linked list, and what traverse means is just go through it, like cycle through the list, and in this case we're going to print it. So we're going to first assign the current song variable to be the head of the playlist, and the head being the first song. So this while loop is kind of interesting because it says while current song. Now current song represents a Boolean value, and that means that it represents a true or false value, or a non-value, which means false. So in this example, if the current song is a real song, like if there is a current song, then while loop is gonna keep running. But if the current song turns out to be none at the end of the list, then the while loop is gonna stop running. And if you're wondering how can the current song even be none, well, up here in the song node class, we've actually defined that in some nodes, when we're initializing it, the next song is none, and when we've reached the last node in the linked list, then that's what it's gonna be. So here we're gonna print it, and then we're gonna print the current song's name, and then we are going to move on to the next song. The way we're gonna do that is we're gonna define a new current song, which is gonna be the song right after our old current song, and this way we're gonna keep cycling through the list, or traversing through the linked list. Now, here we're gonna be searching for a specific song in the playlist. So again, the current song is gonna be the beginning of the playlist, and then we're gonna go through it. So this is basically just like traversing a linked list, except we're adding an extra step here. We're adding this if block, and what this does is it just kind of uses condition flows to kind of determine whether the current song is the target song, or whether the current song is the song that we're looking for. If it is, then we are going to return the current song. If it isn't, then again we're gonna get a new current song, which is gonna be the next song. So we're basically just traversing through the list, except this time we're searching if the song that we're currently on is the target song that we're looking at. And finally, using this method over here, we are using this function over here. We're gonna calculate the length of the linked list. So again, we're gonna have a counter variable, which we're gonna increment by 1 every time we get a new song. So again, the current song is going to be the first song in the playlist, and then while current song, we're going to increment the count, and then we're going to keep moving until the while loop stops, which means that there is no next song because the next song is none. Then we're going to return the count, or whatever the count is, which is the length of the list itself. So here are like some examples of how we can perform these operations on the playlist. So let me just run this piece of code. So again, this is from the traversing the list, where we printed the name of every song, and then this is where we're gonna find if the target song is in the is it in the list. And finally, the final function is get playlist length, and so when we run this function and print it, then the output, as we can see, it is that the playlist length is 3. So this is kind of how linked lists work. This is the code behind them. And now I also want to discuss some like the pros and cons of linked lists, because if this is a new concept to you, you might be wondering, why do I need to use this? Why can't I just use a traditional list? So let's go over the advantages and disadvantages of linked lists. So they have their own strengths and weaknesses compared to other ways of storing data, like lists or arrays. So some of the advantages, I would say, are it's easier to add or remove songs anywhere in the playlist. It's easier and faster. And it doesn't need to allocate a large amount of memory in advance. So it doesn't even use that much memory. So that's, again, the actual scale of how much memory is being used, it's very small. So it might not matter if you're running like these kind of like this minimal examples like this, but if you're running a lot of lists, then in the long term it is faster, and it's a good habit to kind of use methods that are more efficient in memory. But linked lists also, they have their disadvantages. Like for example, it does take a little longer to find a specific song in, let's say if it's in the middle of the playlist, not at the beginning, not at the end, but if it's kind of somewhere in the middle, then it's it's a little more hard coded. It's longer, and that's like one of the disadvantages of the dynamic linked list. And it also uses a little bit. I know I said that it's good on the memory side, but it does use a little bit more memory when we're trying to keep track of the connections between the songs, because again, these nodes are they aren't like a continual list, right? The whole structure of the linked list depends on how the nodes are positioned relative to each other. So linked lists can also have some fancy variations. So let's I'm just going to talk about two of them, and then I'm going to end the video. So we're going to talk about circular linked lists and doubly linked lists. This is just a little bit of the more technical stuff. I'm not going to show you any examples, but I'm just going to kind of go over the theory part of it. So circular linked lists, they're like imagine if the last song in your playlist, it points back to the first song. So like if you're listening to Spotify or YouTube Music or something like that, then maybe you want your playlist to keep playing again and again if you're on like a long road trip or something. So that way you can keep playing songs forever without reaching the end, because when you reach the end, it's gonna go back to the beginning. So that's how it goes. It goes full circle basically. And then there's also such thing called a doubly linked list. And so in doubly linked lists, each song knows about the song that comes before and after it. So that kind of it's not only does it know the song that comes after, but also the song that comes before it. It has that extra piece of information. It's like having a friend on each side, making it easier to go forward or backward in the playlist, because maybe you don't want to skip forward in the song in the playlist. Maybe you also want to skip back. Maybe you really like the song and you want to listen to it again, so that's when it might be useful. So yeah, that's it. We've covered the basics of linked lists in Python, and now you know how to create, traverse, search, and measure the length of a linked list. They're a really useful tool to help organize data, and they come in handy in many programming situations. So that was it for this video. I hope you liked it. Don't forget to smash that like button, subscribe to my channel, and share this video with your friends if you liked it. That's it for this video, and I'll see you in the next one.